Hello students, in this video I will explain the other problems in the exercise 5.1. See this question. Find all points of discontinuity of f where f is defined by f of x is equal to x cube minus 3 if x is less than or equal to 2, x square plus 1 if x is greater than 2. Now f of x is defined for all real numbers. And let us take C be a real number, and there are three chances, that is either C may be less than 2, C may be equal to 2, or it may be greater than 2. Let us take three different cases and analyze the limit of this function. First case, let us take C is less than 2, and when C is less than 2, function is defined like this: x cube minus 3. See here, when is x less than or equal to 2, f of x is x cube minus 3. Therefore, when C is less than 2, f of C is equal to c cube minus 3. You find limit extends to C f of x. Limit extends to C f of x is equal to limit extends to C x cube minus 3, and which is equal to c cube minus 3. And here you can observe limit extends to C f of x is equal to f of c. Therefore, f of x is continuous at x equal to c, where c is less than 2. And let us take the second case, that is c is greater than 2. When c is greater than 2, f of x is defined like this: x square plus 1. See here, when x is greater than 2, f of x is x square plus 1. Therefore, what is f of c? C square plus 1. You find limit extends to C f of x, that's equal to limit extends to C x square plus 1, that is also equal to c square plus 1. And here limit extends to C f of x is equal to f of c, and both the limit of the function and value of the function are equal. Therefore, f of x is continuous at x equal to c. Here c is greater than 2. And now let us take the third case, that is c is equal to 2. First, let us find f of 2. F of 2 is equal to 2 cube minus 3, because when it is 2, it is defined x cube minus 3. That's why f of 2 is equal to 2 cube minus 3, that is 8 minus 3 is equal to 5. And limit extends to 2 minus f of x is equal to 2 minus means less than 2. When it is less than 2, function is defined x cube minus 3. That's equal to limit extending to 2 minus x cube minus 3. That's equal to 2 cube minus 3 is equal to 8 minus 3, which is equal to 5. And you find limit extends to 2 plus f of x. And when it is 2 plus, how the function is defined? It is greater than 2. Function is defined as x square plus 1. And that's equal to limit extending to 2 plus x square plus 1. That's equal to 2 square plus 1. That's equal to 4 plus 1, and which is also equal to 5. Here you can observe limit extending to 2 minus f of x is equal to limit extending to 2 plus f of x is equal to f of 2. And left hand limit, right hand limit, and value of the function are equal. All of them are equal to 5. Therefore, f of x is continuous at x equal to 2. And it is continuous when c is less than 2, when c is greater than 2, and when c is equal to 2. Therefore, the function is continuous function. Now let us take one more question. Discuss the continuity of the function f where f is defined by f of x is equal to 3 when 0 less than or equal to x less than or equal to 1, 4 if 1 less than x less than 3, and 5 if 3 less than or equal to x less than or equal to 10. Here the function is defined only in the interval 0 to 10, that is when x is less than 0 or greater than 10. You need not check the continuity. It is sufficient if you check the continuity of the function in the interval 0 to 10. Here f is defined for all real number in the closed interval 0 to 10, and let c be a real number in this interval. And we will have the 5 different cases, and that is c may be in between 0 to 1, not 1 is not included. And when c is equal to 1, when c lies between 1 to 3, and c lies between 3 to 10, and at c is equal to 3. And you have to take the 5 different cases. In all the cases you have to check the continuity of the function. And let us take the first case, that is 0 less than or equal to c less than 1. And what is f of c? And f of c is equal to 3 here. When c lies between 0 to 1, function is defined as 3. Therefore, what is f of 3? F of c is equal to 3. And limit extending to c f of x. And when it is in between 0 to 1, function is defined like this 3 only. And that is equal to limit extending to c 3. That's equal to 3. And here limit of the function is equal to value of the function. Limit extending to c f of x equal to f of c. Therefore, f of x is continuous at x equal to c, where c is in the interval 0 to 1. And let us take the second case, c is equal to 1. When c is equal to 1, you check the continuity carefully. And how the function is defined, f of 1 is equal to 3. When it is 1, function is defined as 3 only. Therefore, what is f of 1? F of 1 is 3. And the limit extending to 1 minus f of x. 1 minus means less than 1. When less than 1, the function is defined as 3. And it's equal to limit extending to 1 minus 3, and which is equal to 3. And limit extending to 1 plus f of x. 1 plus means greater than 1. When it is slightly greater than 1, the function is defined as 4. And that's why limit extending to 1 plus f of x is equal to limit extending to 1 plus 4, which is equal to 4. Here the left hand limit and right hand limits are not equal. Limit does not exist. Therefore, the function is not continuous at x equal to 1. And let us take the third case, that is c lies in the interval 1 to 3. And if c lies between 1 to 3, what is f of c? F of c is equal to 4. See here, when x lies between 1 to 3, what is f of x? F of x equal to 4. Therefore, f of c is equal to 4. And limit extending to c f of x is equal to limit extending to c 4, because when x lies between 1 to 3, what is f of x? F of x is 4. Therefore, limit extending to c 4, which is equal to 4. And limit of the function and value of the function are equal. That is, limit extending to c f of x is equal to f of c. Therefore, f of x is continuous at x equal to c. And let us take the next case, that is c is equal to 3. When c is equal to 3, function is defined as 5. See here, when x lies between 3 to 10, function is defined as 5. And therefore, f of 3 is equal to 5. Limit extending to 3 f of x is equal to 3 minus f of x is equal to 3 minus means slightly less than 3. When it is less than 3, function is defined as 4. And that's equal to limit extending to 3 minus 4, which is equal to 4. Limit extending to 3 plus f of x is equal to limit extending to 3 plus 5, and which is equal to 5. Here left hand limit and right hand limits are different. Therefore, function is not continuous at x equal to 3. And let us take the last case, that is when c lies between 3 to 10. And when x lies between 3 to 10, f of x is defined as 5. Therefore, f of c is equal to 5. And the limit extends to c f of x is equal to limit extends to c 5, and which is equal to 5. And limit of the function is equal to value of the function. Limit extend to c f of x equal to f of c. Therefore, f of x is continuous at x equal to c. And thus we will have the point of discontinuous. It is at x equal to 1 and x equal to 3, function is discontinuous, and the rest of the points the function is continuous, including the boundary point, that is at 0 and 10. And here we need not verify the continuity at 0 and 10, because 0 minus is not defined here. Limit extending to 0 minus is not defined. Only 0 plus is defined, and we have already verified for c. And limit extending to 10 plus is not required here, because 10 plus is greater than 10. When it is greater than the 10, function itself not defined. So it is sufficient if you verify the continuity of the function in the interval 0 to 10, and at x equal to 1 and at x equal to 3, function is not continuous. And with this much, I'll conclude this video, and in the next video let us continue with the other problems. Thank you.